Hi everyone, I am Pratima Naik. Today we will discuss some word problems from conic sections. Question number 1, very simple question. If a parabolic reflector is 20 cm in diameter and 5 cm d, find the focus. So we have drawn the figure. Diameter is 4 times of depth. Let depth be A and diameter is 20, which is 4 times of A. So it is latius rectum. So where should be the focus? Focus is at the midpoint of the diameter. Question 2. An arch is in form of parabola with its axis vertical. The arch is 10 meter high and 5 meter wide at the base. How wide is it? 2 meter from the vertex of the parabola. Now figure is drawn. From the figure, OQ, height of the arc is 10 meter and the width is 5 meter. OP is height from the vertex is 2 meter and we are asked to find BC. The origin of the coordinate plane is taken at the vertex of the arc in such a way that is its vertical axis is along the positive y-axis. So the equation be x square is equal to 4a. It is given AD is equal to 5, OQ is equal to 10, OP is equal to 2 and we have to find BC. So we can find BP and BC is equal to double of PB. So how will start? Take the point A, its coordinate with respect to origin is equal to 5 by 2, 10 because AD was 5. Now 5 by 2, 10, 10 is a point on a parabola. So putting in x square is equal to 4ay, we'll get 4 times of a is equal to 5 by 8. Next coming to point B. Let B be x, 2. It lies on the parabola. So putting in the same equation, we'll get x square is equal to 2 point something and x is equal to 1.12. Now whole BC is equal to twice x. So it will be 2.23 approximately. So when the earth is 2 meter from the vertex of the parabola, its width is 2.23 meter. Coming to very interesting question. The cable of a uniformly loaded suspension bridge hangs in the form of a parabola. The roadway, which is horizontal and 100-meter long, is supported by vertical wires attached to the cable, the longest wire being 30 meter and the shortest being 6 meter. Find the length of the supporting wire attached to the roadway 18 meter from the middle. Please try to understand what is given and what is asked. So this is the bridge. Its width is 100 meter. Here the supporting wires, the smallest is 6 meter and the longest is 30 meter. Question is, when the wire is 18 meter from the middle, what will be the length of the suspension wire? The shape is a parabola, axis is y-axis, so equation can be written as x square is equal to 4 times of a and y. So now you must have understood from the last figure that point 50, 24 lies on the parabola. So putting in equation we'll get a 50 square is equal to 4 times of a into 24. So this gives us 4 times of a is equal to 2500 by 24. Now we have to get y when x is equal to 18. So 18 comma y is also a point on parabola. Again we'll put x is equal to 18 in the equation, x square is equal to 4a times y. So this gives us y is equal to 3.11. But what is the length of the wire now? It will be 6 plus 3.11. It will be 9.11 meter. Question 4. An arch is in the form of semi-ellipse. It is 8 meter wide and 2 meter high at the center. Find the height of the arch at the point 1.5 meter from the end. The length of the major axis is 8 meter, while the length of the semi-minor axis is 2 meter. The origin is center of the ellipse, while the major axis is taken along x-axis. The equation of semi-ellipse will be in the form of ellipse, where A is the semi-major axis and B is the semi-minor axis. So we'll take the equation here, x square over a square plus y square over b square is equal to 1. So we have seen it is 2 times of a is 8 gives a is equal to 4 and b is equal to 2. So putting in the equation we get x square by 4 square plus y square by 2 square is equal to 1. This gives us the result x square by 16 plus y square by 4 is 1. Now the question is, we have to find the height of the arch at a point 1.5 meter from the end. So see the figure, OA is equal to 4 and AB is equal to 1.5. So BO is equal to 4 minus 1.5, that will be 2.5. So now we have to find the height BP. So P point is equal to 2.5 comma y. So now 2.5 comma y lies on axis ellipse. So x square by 2.5 whole square plus y square by 2 square is equal to 1. This gives us y square is equal to 2.44 or y is equal to 1.56 meter. Question number 5. A rod of length 12 centimeter moves with its ends always touching the coordinate axes. Determine the equation of the locus of a point P on the rod which is 3 centimeter from the end of the contact with the x-axis. Please see the figure. Let A be the rod making an angle theta with OX and P x comma y be the point on it such that AP is equal to 3 centimeter, then PB will be 12 minus 3, that is 9 centimeter. Now from P we'll draw two perpendiculars, one is PQ on OA and PR on OB. In triangle QPA, PQ by PA is equal to sin theta, or sin theta is equal to y by 3. In triangle PBR, PR by PB is equal to cos theta, or cos theta is equal to x by 9. Now squaring both the equation and adding them will get sin square theta plus cos square theta is equal to 1 we know. So x square plus by 81 plus y square over 9 is equal to 1. So this is the required question number 6. Find the area of a triangle formed by the lines joining the vertex of the parabola x square is equal to 12y to the ends of the lattice rectum. Please see the figure. Here triangle AOB is such that one vertex is at origin and the ABR end point of the lattice rectum. So AB is the base. OF is equal to height of the triangle. Now comparing with given equation x square is equal to 12y with x square is equal to 4 times of ay, we get a is equal to 3. So OF is equal to 3. Now AB base is equal to length of the lattice rectum, that is 4 times of A, so it will be 12A. So then area of the triangle will be half into base into altitude. So half into AB is 12 into height is 3. So half into 12 into 3 is equal to 18 square unit. A man running a race course notes that the sum of the distances from the two flag posts from him is always 10 meter and distances between the flag posts is 8 meter. Find the equation of the posts traced by the man. The locus of points whose sum of the distances from two fixed points remains constant is always an ellipse. So we will take a ellipse here whose major axis is x-axis. Let A and B the position of the two flag posts and Px, y is the position of the man, which is a variable point. According to the question, PA plus PB is equal to 10. So that sum is equal to length of the major axis. So that is 2 times of A, because the constant distance is always twice A. The path is an ellipse. So equation is x square by A square plus y square by B square is 1. While the points A and B are foci. Length between two fixed points or foci is always 2 times of AE, or we also call it 2 small c. That is equal to 8. So A is equal to 5 and A is equal to 4. Now B square is equal to A square minus C square or A whole square. That will be 25 minus 16, that will be 9. So equation of the ellipse is x square by 25 plus y square by 9 is equal to 1. Question number 8. An equilateral triangle is inscribed in a parabola y square is equal to 4 times of ax, where one vertex is at the vertex of the parabola. Find the length of the side of the triangle. AOB is an equilateral triangle inscribed in the parabola y square is equal to 4ax. O is the vertex of the parabola and other vertices are A, x, y and B will be certainly x, minus y because it is a symmetric figure. Now AB is the side of equilateral triangle. AB is equal to 2 times of y. Now angle POA is equal to 30 degree because it will be 60 degree, half of the 60 degree. So in triangle AOP, now AP pi OP is equal to tan 30 degree, or AP is equal to y and OP is equal to x. So y upon x is equal to 1 upon root 3. So this gives us the relation x is equal to root 3 y. Now putting in equation of parabola, I'll get y square is equal to 4 times of a, and replacing x by root 3y, I'll get y is equal to 4 root 3a. So side of the triangle will be 2 times of y, it will be 2 times of 4 root 3a, that will be 8 root 3a unit.